Good morning, student. In this lecture we are going to study what is meant by electrode potential, cell potential, and how will you calculate cell potential by using Nernst equation. First of all, what is meant by electrode potential? We know that in galvanic cell there will be two half cells are present. In one half cell, solid electrode is immersed in solution of its own ion of known concentration. Look at here. For example, this is oxidation half cell in which zinc electrode is deep in solution of 1 molar zinc sulfate solution in which zinc plus 2 ions are present, and this is anode. Obviously on anode oxidation reaction takes place by loss of 2 electron by zinc. If this zinc electrode undergoes oxidation by loss of electron, then there will be development of difference in solid electrode and its solution. There will be at the surface of this solid electrode and its solution there exists a electrode potential. Thus potential difference established due to electrode half reaction occurs on electrode surface is called as electrode potential. Then potential associated with oxidation reaction called as oxidation potential. Potential associated with reduction reaction gives reduction potential, and overall cell potential is called as electromotive force, or it is also called as cell potential. Cell potential is algebraic sum of electrode potential at anode and cathode respectively. Therefore, cell potential is denoted by E cell. E cell is equal to, we know that in galvanic cell two half cell are present, therefore E cell is equal to cell potential due to electrode potential due to oxidation reaction which takes place at anode plus electrode potential due to reduction reaction takes place at cathode. From this equation we can calculate overall cell potential. Overall cell potential is algebraic sum of oxidation potential and reduction potential. Then what is meant by standard potential? Standard potential. We know that electrode potential depends on 3 factors. First one is concentration of solution, second one is pressure of gases, and third one is temperature. Then to compare cell potential of different galvanic cell, we have to measure cell potential at same conditions of temperature, pressure and concentration. Therefore, what are the standard conditions of temperature, pressure and concentration? Standard conditions of temperature, standard conditions that means concentration of solution must be 1 molar, temperature is equal to 25 degrees Celsius, that means 298 Kelvin, and if gases are involved, then pressure must be 1 atmospheric. These are the 3 conditions of standard concentration, temperature and pressure. Then potential, electrode potential measured under these standard conditions are called as standard electrode potential. Then standard cell potential is also algebraic sum of standard oxidation potential and standard reduction potential. Therefore, standard cell potential is denoted by E0 cell. Then E0 cell, that means standard cell potential, is equal to standard oxidation potential plus standard reduction potential. By using this formula, we can calculate standard cell potential. But here E0 cell is standard cell potential, E0 oxidation म्हणजे standard oxidation potential, and E0 reduction is the standard reduction potential. Then according to IUPAC convention, standard potential of electrode is taken as standard reduction potential. It must be noted that standard oxidation potential of any electrode is numerically equal to standard reduction potential with reversal of sign. For example, standard oxidation potential of zinc is equal to plus 0.76 volt, then its standard reduction potential will be minus 0.76 volt. That is, both value are numerically equal with only reversal of sign. Then standard cell potential is written in terms of standard reduction potential of electrode. Say this equation as 1. In equation 1, standard oxidation potential is equal to minus standard reduction potential. Then by substituting this value in equation 1, then you will get E0 cell is equal to E0 cathode minus E0 anode. By using this equation, we can calculate standard cell potential. Then Next point is dependence of cell potential on concentration given by Nernst equation. Next is Nernst equation. Dependence of cell potential on concentration is given by Nernst equation. For any general reaction, if for this general reaction cell potential is equal to E cell is equal to E0 cell minus R into T divided by N into F ln of concentration of C raised to C into concentration of D raised to D divided by concentration of A raised to A multiplied by concentration of B raised to B. If natural log, that is ln, is converted into log to the base 10 by multiplying 2.303, therefore E cell is equal to E0 cell minus 2.303 R into T N into F log to the base 10. Here concentration of C raised to C and concentration of D raised to D is nothing but concentration of product. Concentration of product divided by concentration of A multiplied by concentration of B is nothing but concentration of reactants. Then here E cell is cell potential, E0 cell is standard cell potential, R is gas constant whose value is 8.314 joule per Kelvin per mole. T is standard temperature, that means 25 degrees Celsius, which is equal to 298 Kelvin. N is number of moles of electron used, number of moles of electrons used, and F is Faraday, and Faraday is equal to 96500 Coulomb. Then by substituting this value in above equation, this equation becomes E cell is equal to E0 cell minus 2.303. What is the value of R? 8.314. Value of T 298 Kelvin divided by N. N is different for different electrochemical reactions. Therefore, it is as it is. What is the value of Faraday? 96500 into log to the base 10 concentration of product divided by concentration of reactant. Then by solving this multiplication, then we get E cell is equal to E0 cell minus 0.0592 divided by N log to the base 10 concentration of product divided by concentration of reactants. This is Nernst equation. By using Nernst equation, we can calculate cell potential of any electrochemical cell. In this, if concentration of reactants and concentration of products is same, if concentration of product is equal to concentration of reactants, then this becomes 1. If concentration of product and concentration of reactant is same, then this term will be 1, and log of 1 is equal to 0, then this term becomes 0, then E cell is equal to E0 cell. E cell is equal to E0 cell. If gaseous substance is present in cell reaction, then its partial pressure is taken in place of concentration of reactants or concentration of product. If in reaction one of the reactant or product is in pure solids and liquid state, then its concentration taken as unity. Then this Nernst equation can be used to calculate cell potential. For example, how will you use this equation for calculating cell potential? For example, if suppose this is cell for this cell, you have to apply Nernst equation. Then first of all, left hand electrode is anode, that means zinc electrode act as a anode, that is zinc metal undergoes oxidation by loss of 2 electron. Hydrogen gas electrode act as a cathode, that means it undergoes reduction. First of all, we have to calculate value of N, that means number of moles of electron involved in this electrochemical reaction. For this value of N, we have to write cell reaction. First of all, zinc, it gives zinc plus 2 plus 2 electron. This is oxidation half reaction. Second one is H plus accept 1 electron to form hydrogen gas. This is reduction half reaction. In both equation, number of electron involved is 2 electron, therefore value of N is equal to 2. Then by cancelling these 2 electrons, remaining is plus, it gives zinc plus 2 plus hydrogen gas. This is net cell reaction. And for this reaction, we have to apply Nernst equation. Then E cell is equal to E0 cell minus 0.0592 divided by value of n is equal to 2 log to the base 10 concentration of products in this net cell reaction, which are product zinc plus 2 ions in aqueous state, that means its concentration, and hydrogen gas is in gaseous state, therefore its partial pressure can be taken. Therefore concentration of product means concentration of zinc plus 2 multiplied by pressure of hydrogen gas divided by concentration of reactants, that means here there are two reactants, zinc solid. As say earlier, if any reactant or product are in pure solid state or liquid state, its concentration taken as unity, therefore it is not necessary to write in this equation. Then concentration of H plus, here 2 moles of H plus, that means concentration of H plus raised to power 2. From this equation we can calculate cell potential. If, second example, if you have to calculate single electrode potential by using Nernst equation, then how? For example, this is single electrode. This is single electrode and its potential is calculated by using Nernst equation. How? First of all, identify this electrode is anode or a cathode depending on sequence of aqueous or solid state first. Here aqueous state first, therefore it acts as a cathode. And we know that at cathode reduction reaction takes place, therefore zinc plus 2 accept 2 electron, it gives zinc solid. This is electrode reaction, and number of moles of electron involved in this electrode reaction are 2. Therefore E cell, here not E cell because it is single electrode, therefore E electrode is equal to E0 electrode minus 0.0592 divided by En, that means value of En is equal to 2 log to the base 10. In this reaction, concentration of product is zinc solid. It is in pure solid state, therefore its concentration taken as unity divided by concentration of reactant, that means concentration of zinc plus 2 ion. By using this equation we can calculate any single electrode potential or cell potential by using Nernst equation. In next lecture we are going to study Gibbs energy and cell potential.